Hello. In this section, I will go over how to derive using power rule, constant rule, and constant multiple rule. So we're pretty much taking the derivative using power rule. So there's not much rules you have to know. You just need to know the constant rules. So this rule states that the derivative of a constant is always going to be 0. And this rule states the derivative of x to the power of 1 or any letter raised to the power of 1 will always be 1. And then the power rule, that this means it's n times x raised to the n minus 1. So I'll go over that when we do an example. And it's pretty simple. And then if you have a derivative with a constant, just take the derivative using power rule and just leave the constant in front. Okay, so I will show you how to, I'll do some examples. So it says, find the derivatives of the following functions. So let's start with example 1. Find the derivative of y equals 8. Well, the derivative of a constant is always going to be 0. So the derivative of this is going to be y prime equals to 0. Okay. So anything with a number or anything without a letter is always going to be 0. Okay, let's move on to number 2, example 2. So let's find the derivative of y equals x to the 6. So we're going to use power rule. So how you do this is all you got to do is put the power, the original power, in front of the x. And then the new power is going to be whatever this number is, which in our case is 6, minus 1. So you literally subtract 1 from the power, from the original power. So when you clean that up, that would be 6x to the 5th. It's, yeah, that's simple. Okay, this one, example 3, y equals 1 over x to the 7th. Notice that it's in a fraction form or a rational form. Later on, you'll learn that you can derive this using the quotient rule, but I would not do more work than you have to. So what I would do is, if you could avoid the quotient rule, you should. I'm going to rewrite this as using a negative power. So 1 over x to the 7th can be written as x to the negative 7, right? Then we just got to apply the power rule. So it's going to be y prime equals negative 7x. And then it's going to be raised to the negative 7 minus 1, right? So that would be y prime equals negative 7x to the negative 8. And that's it. That's it. I mean, sure, you can put it in positive power. So if you want, you don't have, unless they say so. You can also rewrite this as y prime equals to negative 7x, or actually negative 7 times 1 over x to the power of positive 8, right? So that's how you write a negative power into a positive. So you can rewrite this as negative 7 over x to the 8th. It really, these two are the same thing. So I don't think it matters unless they ask you to put final answer in positive power. Okay. This one, this looks kind of strange because you're so not used to taking the derivative of the fifth root, a square root, right? So what we would do is rewrite this as a power. So f of x, the fifth root of x in power form could be written as x to the 1/5. And then from here, what you could do is just take power rule. Power rule. So it would be f prime of x equals, put this number in front of x, so it's 1/5 x, and then the new power is going to be 1/5 minus 1, right? So let's simplify 1/5 minus 1. So 1/5 minus 1. So I can rewrite 1 as 5 over 5, right? 5 over 5 is the same thing as 1. So that would be 1 minus 5 is negative 4, and then to the 5th. So your final answer could be expressed as f prime of x equals to 1/5 x to the -4/5, right? And yep, that's it. This one, example 5, find f of x equals x plus 1. So to take the derivative of this, you just you apply the power rule and the constant rule, right? So the derivative of x to the 1, according to the rule, to this rule, it says the derivative of x, anything raised to the 1, it's always going to be 1. So the derivative of x to the 1 is just going to be 1. And then the derivative of a constant is always going to be 0. So your final answer is going to be f prime of x equals to 1. Okay, now this take the derivative of this polynomial. So what you could do is just take the derivative of each term. That's what I would do. So it's going to be f prime t. So for this term, how do you take the derivative? Using power rule, right? So 2 times -2 is -4 t, and then the new power is going to be 2 minus 1. I'll clean that up later. And the derivative, so you have a power 1, and then you have a constant. So what you're going to do is leave the constant alone. And what is the derivative of t to the 1, or anything raised, a letter raised to the 1? It's always going to be 1. And then what is the derivative of -6? It's just 0, a constant, right? Constant, -6 is a constant, so that's why it's going to be 0. So when you clean this up, this is f prime of t equals to -4 t, and then 2 minus 1 is 1, plus 3 times 1 is 3, minus 0, right? Which is just 0. So this is your final answer. Okay, let's do this one. Example 7. The derivative of x squared plus 4x to the cube. So just take the derivative of each term. So the derivative of x squared, you put a 2 in front of x, so it's going to be 2x. So we're using power rule, right? And then the new power is going to be 1 because it's 2 minus 1. This one, the derivative of 4x to the cube. So what you're going to do is multiply the 3 by 4. So 3 by 4, or 4 times 3 is 12. And then the new power is going to be 1 because it's 3 minus 1, which is 2. And that's your final answer. Okay, the derivative of this polynomial, let's see. It's going to be s prime t. So take the derivative of each term. So we have like 3 terms. So what is the derivative of t to the third? T to the third. You're going to put 3 in front of t. You're going to put, and it's going to be t, and then it's going to be 3 minus 1, which is 2, right? Okay, and then the derivative of negative 2t. So -2 is a constant, and then the derivative of t to the 1 is just 1. And then the derivative is 4, or a constant, is going to be 0. So when you put that all together, you get s of t equals to 3t squared minus 2 and plus 0. So this is your final answer. Okay, example number 9, we have f of x equals x cubed minus 3x squared plus 4 all over x squared. I would not use the quotient rule. You could, but I would not use it because the quotient rule does take some work. So what I would do is divide each term by x squared. So yeah, so this, you can do that, right? You could divide each term by x, by this term. So this is like saying x cubed over x squared minus 3x squared over x squared plus 4 over x squared. And when you clean this up, this would be when you're dividing with power with the same base, you subtract. So this is going to be x to the 1, because 3 minus 2 is 1. And then the derivative of this is just the x2 cancels, so you're just left with -3. And then the derivative of 4 over x, I think what I would do is rewrite it as a negative power. So 4 over x squared can be written as 4x to the -2, right? And what's the derivative of 4x to the -2? You use power rule. So -2 times 4 is -8x. And then the new power is you subtract 1. So it's going to be -2 minus 1, which is -3. Okay. So this is going to be f prime of x equals to x minus 3. Whoops. The derivative of a constant is not -3, it's 0, right? So this is going to be -0, and then we already took the derivative of 4x to the -2, which is -x to the -3. So your final answer is going to be f prime of x equals to x minus 8x to the -3. Now, what if you want to use only positive power? So how would you write this as a positive power? So you can write it as f prime of x equals to x minus 8, and then x to the -3 using only positive would be 1 over x to the 3rd. So you could rewrite your final answer as this: x minus 8 times 1 over x third is 8 over x third. So I think either answer, so this would work, and this also would work. Okay. Well, I guess that's it. That's it for this section. Thank you.